So in the last class, we are discussing about the k-means clustering, right? Last class, we have discussed about the k-means clustering, where k-means clustering is working on the mean. So just it is identifying the nearest one. So similar kind of KNN, how in the KNN we are having with respect to, how in KNN we are having the k nearest neighbors, Similarly, in the k-means also, we are taking the k nearest one. Whatever the nearest, k nearest means in terms of for this data point, whatever the nearest 5 values are there, right? Here also we are going to do the same. In the k-means clustering also, we are identifying with respect to the distance only. We are taking the distances and whether this number of clusters, k depends upon the number of clusters. How many clusters we have to work, right? Where KNN is working on the distance formula and k-means also works on the distance formula. Both of them common thing is distance is common. So here also we are going to apply the Euclidean distance in terms of Euclidean distance. And here also we are going to apply the Euclidean distance. Distance is common. And this is comes under supervised machine learning. This is supervised machine learning. This is unsupervised machine learning. Unsupervised machine learning means where it is working on with respect to output variable. Here there is no output variable. Now the next one is here. This is working on the classification algorithm. It is working on the clustering algorithm. And here we are going to do the prediction and do compare with the actual value. Means we are going to do the evaluation, prediction and followed by evaluation. Here we are going to do only the prediction. No evaluation will be done. Okay. So we are not going to compare with the original one. Evaluation will be done based on the difference between the comparison. Evaluation is nothing but comparison between original, that is actual value, versus predicted value. The comparison between actual versus predicted. Here there is no evaluation will be done because there is no actual values. Okay. So we can't do the predictions, right? So this is a difference between KNN and k-means. In the last class, we have discussed about the k-means algorithm, theoretical part. Now in the today's class, we have to see the practicality of k-means clustering. So before moving to the k-means clustering practicality, let us come see this hierarchical clustering, another type of clustering technique, and we'll do the both of the things at a time, right? Yes, the coding part of k-means we are going to do in the today's class. Now, hierarchical clustering, HC means hierarchical clustering. So hierarchical clustering means, what is the meaning of hierarchical clustering means? It is going to create a hierarchy. What is the meaning of hierarchy means? Very simple. For example, in this any college, as everyone knows college, how the college will work, right? Generally how the college will work, everyone knows. So in a college, we are having with respect to the chairman, the college chairman who has founded the college, the founder and chairman, right? Now, within this chairman, we are having with respect to multiple teams are there. One is directors. The directors related to academics. He will see only the academics related to syllabus, related to classes, related to timetables, all these things. So we are having one more director related to administration. He will work on the administration part. That is fees collection part and how to collect the fees, all these things. So next we are having with respect to other things like maintenance, director of maintenance. He will have with respect to the maintenance of college buses or with respect to maintenance of electricity and with respect to some kind of playground, all these things he is going to maintain. Okay. So faculty salaries, everything will be done by the administration department and the faculty's everything. And whether the faculty are engaging with the students and delivering the good content or not will be checked by the director of the academics. Under this director of academics, again, we are having the HOD of CSE department HOD, IT department HOD, and EC department HOD. Whatever the departments are there, each department HOD. Under the HOD, again, we are having with respect to the professors, associate professors or assistant professors, whatever it is. So like this, if you form the list from the top to bottom, if you form the list, this list is called as hierarchy. This list from the top to bottom, if you form like this, then it is called as hierarchy. So hierarchy means now these all of them belongs to one cluster. HODs and director of academics, these all belongs to with respect to one cluster. They will see with respect to the classes. Okay, with respect to the subject. The requirement is with respect to the subject to deliver the maximum content to the students and in order to get the placements or whatever the things. So whereas administration work is the director under him will have with respect to some kind of deans will be there, or with respect to some departments will be there. Again, the departments like like accounts department, right? Some kind of faculty, everyday's faculty is coming or not. That is checking department. All these multiple departments will work in this administration. So these people will make sure that administration works properly. Whereas these people maintenance with respect to maintenance, they will check with respect to in the college, the inverter is working or not, or electricity is proper or not. And with respect to the playgrounds are clear or not, the grass cutting. Okay, if there is a grass on the ground means they'll use to cut the grass. All these things will be done by this department. Each of them are independent to each other. So the director of academics is not going to check the maintenance. For example, if you go and say tomorrow, sir, college ground is not proper, sir, and we are having the period for playing one class, 1 hour period is there, but the ground is not proper, means they'll ask to give a complaint to the director of maintenance only. This director is not going to involve in that. So each of the team is going to separate and they'll work so that the overall work will be easy. Okay, the overall work will be easy. The person who is going to do the digital marketing is different. Okay, the person who has scheduled the demo is different. The person with respect to admin is different. The faculty is different. And finally, the placement team is different. I have not done the digital marketing. Okay, for you all, I have not done the digital marketing. For your batch, I have not done the digital marketing. I have not scheduled the demo. The Naresh IT team, one of the member only has scheduled the demo and you have attended the demo sessions. And if you are facing any kind of issues, your fees receipts or the fees, they are going to check all these things. I am not going to do that one. I will never see whatever the fees you have paid, and I don't know what is the fees you have paid also till now. So just that is the work of admin work. My work is to deliver the content. This is my work. Deliver the content. For each of them, the particular persons are allotted. My work is to deliver the content with maximum and best. This is my work. I am doing my work. Furtherly, related to the placements, again, the placement team is going to coordinate with you. For example, you are tomorrow you are going to take the NASCOM exam. NASCOM separate team is there. Your creation of ID, password, and if you are facing any kind of login issues at the time, this team is going to help you. I am not going to do anything in that. For example, your NASCOM ID and password is not working. You can't intimate to me. If you intimate to me also, I will share only NASCOM team only. I will share you one number and I will ask you to call to this number only. There is a separate team for that. Right? So like this, each of the team word is there, right? Team is called as cluster. The team is called as cluster. Here, digital marketing team is called as digital marketing cluster. They will do the digital marketing work. This team, this team particularly, placement team, whatever the placement team is there, this particular placement team will coordinate with the HRs of the different companies. Okay, they'll make sure that they'll have a good placements. This is entirely different one. I'm not going to do that one. Placements, I'm not going to do anything. And NASCOM, I'm not going to do anything. I will deliver the maximum content and the best content where you can get the easily the placement and easily you can qualify in the NASCOM exam. But tomorrow, what is the schedule? You have to schedule an interview. For example, Naresh IT, in the next month, 20th, we are, there is one company which is visiting the Naresh IT campus, right? Next month, 20th. Assume, example only. If that is the scenario, in that scenario, this placement team is going to send the SMSs to all the students. I'm not even having your phone numbers also. I'm having only your mail IDs. I don't know till now your names also. None of the student name also I don't know in your batch. Right? Just I'm having the mail IDs, that too to add in the Google Classroom. I'm the head of the only Google Classroom, Google Drive. That too only the my content. For my content only. Even videos also, I'm not even the student of videos Classroom also. Right? So here they have divided everything. in order to make the smooth work. So here the things are there, right? This is called as clustering. Why they have done this type of clustering? Everything can be done by one team only, right? But what happens if everything will be done by one team is automatically clumsiness will be there. Okay, proper communication will not be there. At the end, students will not be, this much of students will not be in the narration IT. Just 10 students or 20 students per batch will be there. Right? So proper things are done means that is called as with respect to clustering. Clustering makes the work easy. Even in the government also, CM will not do all the things, right? Again, CM will have with respect to the principal secretary. Under the principal secretary, again, multiple departments will be there. For each department, one director will be there. Under that department, again, sub-departments will be there. Inside that, again, the secretaries will be there like this. The entire, similarly in the police department also, DJP, whatever the head of the Director General of Police, DGP. Under the Director General of Police, again, IGs will be there, AGPs will be there, ADGPs, and multiple teams will be there. Under IG, again, SPs will work. Under the SP, ASP is there. Under ASP, CI is there, SI is there, like this. Under AGP, again, with respect to Commissioner of Police will be there, Assistant Commissioner of Police, and Deputy Commissioner of Police. And under them, again, with respect to the police department. Again, each of them. So this type of hierarchy, creating the hierarchy is called as hierarchical clustering. Okay, this is cluster. This is one cluster. This is one cluster. Okay, SP will report to the IG only, DIG or IG only. Whereas Commissioner of Police will report to the DGP. These people are civil servants. These people are with respect to state servants. These are Indian servants. So again, we are having different. So when compared to this, similarly in animals also, dogs are there. All the dogs are not same, right? In the dogs, we are having different dogs are there. One is family dogs are there. Some of them are very friendly for families. Some of them are security purpose. Okay. Some of them are for identifying the purpose, like police dogs. Okay. Like German Shepherd. Okay. German Shepherd comes under this one, where police dog, they'll smell and they'll identify the thieves. For security purpose, like Doberman. Like family purpose, we are having Labrador. Okay, Labrador or Pomeranian or something. These dogs comes under family. These dogs comes under security. These dogs comes under with respect to identifying. So in the house, we can't maintain with Doberman, right? They'll not be friendly with the entire family members. Okay, any new person comes means they'll attack immediately. We can't leave them inside the house as it is. For example, earlier I used to have this Doberman. I have kept normally. This is a friendly dog only, right? But with the family only, it will be friendly. Any new person comes means immediately, if you open the door, immediately first attacks. After that only it will neutral. First attack, after that neutral. Whereas this one, first neutral, if you ask to attack only, they will attack. Otherwise, they will not do. They will be normal. Right? So Labrador or German Shepherd. Sorry, not German Shepherd. Golden Retrievers, Labrador Retrievers and Golden Retrievers, Pug Dogs, Hutch, right? So this making the hierarchy, creating the hierarchy where this belongs to one cluster, right? So these are called as hierarchical clustering. Hierarchical clustering means builds a hierarchy of the clusters. Okay, hierarchy of the clusters. See, this is overall all the types of dogs we are having. But within this, these are the different dogs. Again, these are the different dogs. These are the different dogs. They belong to different categories. As I have told you, right? Overall, everything is dog only. But within the dogs, again, furtherly it is classified. Again, within the family dogs also, again, it is furtherly classified. Some people will like more hair. Some people will not like the hair of the dog. If the hair of the dog continuously falls in the house means, they will be not interested. Some persons will be interested with full of hair. So they'll feel friendly. So each type of the persons, for different categories, we are having different types of dogs are available. Right? So this is with respect to called as hierarchical clustering. Now here we are having with respect to the before to hierarchical clustering, this is the scatter plot, and after the hierarchical clustering, this is the scatter plot. So yesterday also I have shown you the same kind of example, and after the K-miss, it has been converted. So here also before hierarchical and after hierarchical. Now, how it is going to form this one is, we are having same as k-means, but the process is different. What is this process? So here in the hierarchical clustering, we are having two types of hierarchical clustering. One is called as agglomerative and one is called as decisive. What is agglomerative means? From the bottom to top, if you go means, then it is called as agglomerative clustering. From the top to bottom, if you come means, then it is called as decisive clustering. Right? So both are same only. But if you see from the down to top means, then it is called as agglomerative. From the top to bottom, if you see means, it is called as decisive. Both are same. At the end, both are same. Right? Now, what is the steps involved in this means? So these are the steps. First, you have to make each data point into single point cluster. How many records are there? Each one is one cluster by default. 200 records are there means 200 clusters. 10,000 records are there means 10,000 clusters. 5 lakhs records are there means 5 lakh clusters by default. First one is, each data point is one cluster. Take the two closest data points and make them into one cluster. First, you take the two closest data points and make them into one cluster. And like that, again, you take the two closest clusters and make them into one cluster. And continue this process till you get the one cluster. This is the process. Okay, you have to continue the step 3 till you get the one cluster as the final answer. And model is completed. Take the steps, I will explain one by one. So let us take an example. So here, take the two closest data points and make them as one cluster. Take the two closest data points. So data points, two closest data points, how you can identify whether they are closest or not means based on the distance formula. Once again, you are going to use the distance formula, that is Euclidean distance formula, same to same. Now, take the two closest clusters, two closest clusters and make them as one cluster. We are having like this. Now, how this one will work means, how we can calculate distance between two clusters. This is one cluster, this is one cluster. How we can calculate the distance? For example, here one more cluster is there. Okay. For this cluster, whether this is close or this is close, how we can identify means, distance between two clusters, how we are going to do means, distance will be calculated based on the closest data points. So for this, whatever the last point, and for this, what is the starting point is there, based on the closest data points, we are going to calculate the cluster. The distance we are going to calculate. And second one is farthest data points. This is the second option. Third option is average distances. Average distances means from here to here, from here to here, from here to here. Okay. Similarly, this one also. All the distances to all the distances. Everything to everything. So you are going to calculate every distance to every distance, and overall you are going to take the average. That is called as average distance. Right? So here I am having total 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6 into 5, total 30 distances you are going to calculate. Okay. For this 5, 1, 2, 3, 4, 5. Okay. For this data point, 5 distances are there. For this data point, 5 distances will be there. For this data point, 5 distances. For this data point, 5 distances. For this data point, 5 distances. And for this data point, 5 distances. Total, you are going to get 30 distances. 30 distances, you are going to take the average. Divide by 30. You are going to take distance 1 plus distance 2 plus distance 3. All the 30 distances up to 30. Divide by 30. This is called as average distance. That and option 4 we are having is distance between the centroids. Distance between the centroids. Directly first for this cluster, what is the centroid you calculate. For this distance, what is the centroid you calculate. Example, let us take like this. Let us take like this. For example, I'm having the, okay, 3 clusters are there. Which 2 clusters are very close to each other? Whether these 2 are very close means combine those 2. If these 2 are close means combine these 2. If these 2 are very close means combine these 2. So first you have to calculate this is cluster 1, cluster 2, cluster 3. So cluster 1, cluster 2, cluster 3. Cluster 1, cluster 2, cluster 3. So first you have to calculate the distance between cluster 1 versus cluster 1, which is 0. Cluster 1 versus cluster 2. So you have to calculate the distance between these 2. how you are going to calculate the distance between two clusters means by using any one of the option. For example, I'm using the centroid is the option. So first I'm calculate the centroid of this cluster, centroid of this cluster, centroid of this cluster. First I will calculate distance between C1 versus C2. The distance I have got as some 5. I will calculate the distance between C1 versus C3. I will write that distance, which is 7. The distance between these two, I will get the distance as some 4. Now, since the distance out of these three, 4 is the closest one. So I'm going to combine these two. Is that clear? So like that, you are going to combine the closest to two clusters. Okay. Into one cluster. So just observe this one. So this shortest distance is called as single linkage. Single linkage means it is going to identify the distance between two clusters. For example, guys, let us take an example like this. There is a one city, city 1 called as Hyderabad. Hyderabad means not the only one point, right? Hyderabad means a big one, right? In one end, we are having LB Nagar. In one end, we are having with respect to Patancheru, right? So with respect to Miyapur, whatever it is, one end we are having with respect to this one end we are having LB Nagar. As per the metro, we'll take the values. Okay. So one end we are having LB Nagar, one end we are having the Miyapur. Now one more city, city 2 is called as Mumbai. So Mumbai also is having a very large one. I don't know the starting point and ending point, but it is having also large one only, right? The starting point and ending point will be there for city, for Mumbai city also. Now, if you are traveling from Hyderabad to Mumbai, now what is the distance? You're on the national highway. If you go on a national highway by road, you'll see some kind of distance till the distance left for Mumbai is 300 kilometers. You'll see something like this, right? 280 kilometers or 290 kilometers or whatever the number you are going to see on the national highway. How that national highway number was there, from where to where they have calculated, from Miyapur or to this point or from LB Nagar to this point? From which point to which point they have calculated that one? It is from central bus stand of Hyderabad to central bus stand of bus station of Mumbai. Whenever you are moving on the road, they are considering based on the bus stand to bus stand. For every city or every town, every village will have one bus stand. That bus stand to bus stand is the distance. If you are traveling by air means airport to airport is the distance. If you are traveling by train means railway station, main railway station to main railway station. Within that city, multiple railway stations are there means one is the main one will be there, right? That main railway station to main railway station. So they are considering in that way. That is the distance. They are not going to take the shortest distance. They are not going to take the longest distance. So they are having one particular thing. Similarly, here also within the center, here in this particular example, here we can either go with either shortest distance or longest distance or average distance or centroid distance, where centroid distance is the standard one. Okay, but you can select in the Python coding, you can select this one as per your choice. If particularly you want the shortest distance and make based on that only you want to make the clustering miss, you can select the shortest one also. That is called as single linkage. This is called as complete linkage. This is called as average linkage. And this is called as centroid linkage. Centroid linkage means distance between the centroids. Average linkage means average distances between the clusters. These are the multiple options which we are having. Right? So these are the various multiple options we are having. Now, let us take a data set where I'm having only 6 data points are there. For this, I want to make a hierarchical clustering. First 6 data points. What are the steps you have written? What is the first step? How many data points are there? You have to make the n number cluster. So here 6 data points are there. 6 I am making into 6 clusters. 6 of them are 6 different clusters. 6 different colors I have given. What is the second step? Distance between the shortest distance between the data points, make them into one cluster. So these two are forming into one cluster. Similarly, these two are forming into one cluster. After that, now this one is forming the cluster to this one. This is forming the cluster to this one. And finally, this one. Right? The same thing, I'm going to apply the hierarchy. The hierarchy representation is called as dendrogram. Whatever the tree type structure is there, right? The tree type structure is called as hierarchy. hierarchy, whatever the hierarchy we are having, the hierarchy tree, whatever the hierarchy tree is called as dendrogram. The hierarchy tree is called as dendrogram. Okay, how we can draw the dendrogram is just observe, don't write simultaneously, just observe now. This will be very simple. Just you have to take the whatever the number of data points are there, just represent all the data points on the x-axis. Represent on the x-axis whatever the data points are there. 6 data points, write P1, P2, P3, P4, P5, P6. That's it. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Now, first you have to identify the distance. You have to take the distance matrix and we have to identify which is the closest two distances. I have identified these two are very close to each other. Now, the two close to each other means some distance is there, right? Some distance D. Whatever the distance you have got, using that distance as the height, you combine these both of them. For example, distance is 1 means take up to a height of 1. Wherever the height of 1 is there, draw a height of 1, these both of them. Attach these both of them. Okay, whatever the distance is there. Distance is 25, up to height of 25. Whatever the distance. So whatever the distance you are having, that distance you are going to take on the y-axis. Y-axis is nothing but Euclidean distance. Just you are going to combine these two of them and you are going to form. That is P2 and P3. In this case, P2 and P3 are very close to each other. So I am going to combine these two. Similarly, here P5 and P6 are very close to each other. So I am going to combine these two. Now this point, whatever the P1 is there, P1 is close to this one or P1 is close to this one. How I can calculate means first I will calculate the centroid. From the centroid to P1 I will calculate. For this centroid I will calculate the distance to P1. If the P1 is very close to this one, I am going to add the P1 to this one. If the P1 is very close to this one, the P1 I am going to add to this one. To which one it is very close, that one I am going to collect. So this P1 is very close to this one. So I am going to add the P1 to this cluster. Now this P4 is close to this one. So I am going to add the P4 to this cluster. And finally everything into 1 like this. Is that clear? Now from this we can identify these two are very close to each other. These two are very close to each other. And whereas 0.4 is comparatively close to this one only. For example, this is China and this is Russia. China and Russia are very close to each other. India is close to this group. When compared to Germany and France, Germany and France are very close to each other. For that, US is very close. Right? So recently, Russia-Ukraine war, everyone has seen, right? And it is going on presently also. Now inside that, whenever there is an option, they are going to check with respect to who are friends to each other. Right? So like this, they are checking with respect to by applying the hierarchical clustering, who are close to each other. Right? So real-time example, one more example with real-time. So this is a Canada, country is Canada, where I am having the multiple cities. Okay, 1, 2, 3, 4, 5, 6. Total 6 cities are there. Now these 6 cities, I want to make a hierarchical clustering. How I am going to make this? The first one, city 1, city 2, city 3, city 4, city 5, city 6. Same, all the 6 cities. First I am going to calculate the distances from this city to this city. So TO to TO, OT to OT, all diagonal elements will be 0. And lower part and upper part will be the same. Right? Now here I am having this one. Now out of these, all of them, which one is very close to each other? Which part is very lowest value you are having? OT and MO. This part, right? This is the least one. So first you combine these two into 1. OT and MO. Okay. Once you combine these two, now you can't separate them. You can't separate now. Again, you can't go with the TO. You can't add with the OT separately. TO should be added only to the cluster only. You can't add to the single value. Once they are clustered means now they are group. Now you can't add to a single person of the group. You have to add this one to a group only. Now this is the original one. From city to city, this is the distance matrix. Now once this was clustered, now you are going to calculate. Now the distance matrix, how we are going to get is TO. Second one is OTMO. This is already one combined. Next VA, next ED, next WI. Now, earlier you are having 6 rows and 6 columns. Now you are having only 5 rows and 5 columns. And you are going to recalculate once again the distance matrix. Once again, you have to calculate, refresh the distance matrix. And after that, you will identify that TO is very close to this one. So you are going to combine that one. Now, this is entirely one set. Now, again, you are going to calculate refresh. Once again, you have to calculate the distance matrix separately. Okay. Now, which one is very low? This one is very low. That is, VA is very close to ED. So these two you have to combine. Now, again, you have to calculate the distance matrix. Now, this WI is very close to this cluster. You are going to combine. And finally, you are going to get. So like this, you are going to cluster them. Is that clear? Example is clear now? So first, you are going to group. For example, let us assume there are 5 students. Let us take 5 students are there. Student 1, student 2, student 3, student 4, student 5. Okay, 5 students you are having. First, you are going to identify which 2 students are very close to each other. And you have identified S3 and S1 are very close to each other. S1 and S3. Combine them. Okay. Now, this matrix you have calculated between S1 versus S3, S2 versus S3. Now, you should not calculate between S1 and S3. You have to take S1, S3 as one cluster. S2. Similarly, S1, S3 on this side. And S2. Now, this will not be there. Again, you have to recalculate. Now, you are going to recalculate between S1 versus S1, S3 cluster to S2. S1, S3 cluster to S4. S1, S3 cluster to S5. The distance you are going to calculate. Earlier distance is S1 versus S2, S2 versus S3. Separately you have calculated. Now, cluster to the point. Cluster to the point you are going to calculate. Now, after this, you have identified with S4 and S2 and S4 are very close to each other. Okay, assume S2 and S4 are very close to each other. So, you are going to take S2 and S4. You are going to combine these two of them. Combine these two. Okay, now once they are combined, means you can't separate them. Now, you have to calculate the distance between S1, S3 versus this one. Similarly, the distance between S1, S3 versus S5. Similarly, this one. So, you are going to recalculate once again. Now, for example, these 2 groups are very close. Combine these 2 groups. First, you combine these 2 groups. Followed by S5. S5 is close to like this. As per whatever it is there. Whatever the values are there, according to that, you are going to calculate. Is that clear? Which one is close? According to that. For example, S5 is very close. S5 is very close. S5 is very close to this particular cluster. For example, S5 is close to this cluster. Draw the S5 and first you combine these two and finally combine overall cluster. Okay, what are the distance you have got according to that? Right? So, let us take an example. Let us take with an one example, manual calculation I will only do. That is age. Age of students 21, 22, 24, 28 and 36. Okay. Now we are having only 5 students and I want to make the hierarchical clustering between these 5 students. S1, S2, S3, S4 and S5. Now, first I will start with S1, S2, S3, S4, S5. S1, S2, S3, S4, S5. Calculate the distances. Distance between S1 versus S1, 0. S1 to S1, S2, S3, S3, S4, S4, S5, S5, 0. Now, distance between S1 versus S2. What is the distance? Square root of 1 square, which is 1. S1 versus S3. 3 square, which is 3. Square root of 3 square is 3. Square root of 7 square, which is 7. Square root of 15 square, which is 15. Similarly, S2 versus S3. 2 square, 2. 4 square. Sorry, 4 square, not 4 square, 6 square. 6 square, so 6. 14 square. Okay, square root of 14 square, square will cancel. Directly the distance is equal to, in our case, advantage is only one column is there, x2 minus x1 whole square, square cancels, only x2 minus x1. So the distance formula is just s2 minus x1, right? Now 24 minus 28, 4, 24 minus 36, 12, 28 minus 36, 8. You are going to write the table like this. This is the first table, table number 1. From this table, identify which two of them are close. That's it. You have to identify only one. Whichever out of all the table, only one only you have to identify. The least one only you have to identify. The least one is, you should not go with the zeros. Don't say 0 is the least one. Apart from the 0, what are the least values there? That is, this one is least. That is distance between S1 and S2. So combine S1 and S2 like this. Okay, with this completed, story completed. First step was completed. Now step number 2. Now again you have to start the distance matrix. Now distance matrix you have to draw S1 and S2, S3, S4, S5. S1, S2, you can't separate now. Once they are combined means you have to take combination only. S3, S4, S5. Now again this is going to be 0. Now distance between this cluster to this one. So cluster to that one means first I am going to take the average of these two. That is centroid. Centroid is 21.5. So now 21.5 versus this one. What is the answer? 2.5. Right? Distance between these two. What is the answer? 21.5 minus 28. That is nothing but 6.5. This one minus this one, which is nothing but 14.5. Similarly, S3, this 2, 4. This one, that is 12. This one, 8. Now, out of these, all of them, which one is close? S1, S2 with S3 is the closest one. So, this is the least one. So, you have to take the S3 here and you have to draw a line like this. Combine these two. With the cluster, it is close. Not with the single S2. With the cluster, S3 is close. Now with this is also completed. Now next you have to take new distance matrix. What is the distance matrix? Is S1, S1, S2, S3, okay, 1, S4, S5. Similarly, S1, S2, S3, S4, S5. 0, 0, 0. Now, with this cluster, the distance between S4. So, take the average of these three. What is the average of these three is? 67 divided by 3, which is nothing but 21.33. Sorry, not 21 point, 22.33. So, now 22.33 versus 28. You are going to calculate that one. So, what is that one? 67. 5.67. Right? 5.67. Next one is this one, which is nothing but 13.67. Next, S4 versus this one, which is 8. Now, again, you are going to calculate which one is the least. S4 is this one. To this cluster, this is least. So, you add this one to the S4. For that, you add the S5. Finally. Right? This is the hierarchical clustering for the given data set. In this data set, like this I have got. You are not going to get for every data set like this. For this data set, I have got like that. Okay. For example, you are having here 35 is there. Now you will get a different hierarchical clustering. It will not be the same. Add instead of 28, go with 35. Now the hierarchical clustering will be different. It is not the same. As the record changes, the distance changes. As distance changes, the dendrogram changes. Now S4 and S5 will be very close to each other. And you are going to get a dendrogram in this way. If you see, you can get the dendrogram in this way. Means these two are friends and these three of them are friends. Basically, these two are very close friends. For this batch, this is okay, friend. Right? Is that clear? Done? So that is the formation of dendrogram. Dendrogram is formed based on the cluster. If you want, you can try. You can take the note. Take the assignment. Assignment is nothing but take these 5 values. There. So you are having only the age of the student. Only one column is there. That too 5 students are there. 21, 22, 24, 35, 36. For this, draw the dendrogram. How to draw the dendrogram is every time you have to calculate the distance matrix. Every time you have to draw the distance matrix. So the distance matrix, I'm going to here, after you draw the dendrogram, you are going to get the dendrogram in this way. S1, S2, S4, S5. In between S3. S3 is close to this one. Overall, you are going to combine like this. You are going to get a dendrogram in this way. You can check. Okay. After doing the calculation, you can check. You will get a dendrogram in this way. Right? Because the distance between these two is just 1. These two also just 1. So obviously these two will be very close to each other. Just I am applying the distance concept, nothing else. Okay. Done? This is your assignment. Just you do the distance matrix. Every time you calculate the distance matrix. Whenever you want to combine the cluster and cluster or cluster with a single point, that cluster you take the centroid point first. From the centroid you calculate the distance. So that your work will be easy. If you want to take with the for example, this point with the closest data point, for example, small, which are closest to data points means this is the closest data point. Which is the farthest data point means this is the farthest data point. If you want to apply like that also, you can apply. Simply you want to apply the centroid means go and apply the centroid. Is that clear? So how to form the dendrogram and hierarchical clustering. Everything is clear? Formation of hierarchical clustering. So this hierarchical clustering height, whatever the height is there, this height is not we are going to write as per our choice. This height is the Euclidean distance height. Whatever the distance of this one, this height, whatever the height is there, this height is Euclidean distance between these two. Whatever the Euclidean distance you got between this one versus this one, that is the Euclidean, the height is Euclidean distance. Now to as per your choice. The height is the Euclidean distance. Whatever the Euclidean distance you have got, that is the height you have to take. Done? Is that clear? So earlier example, whatever the example I have given you for the example like 21, 22 and 24, 35, 36, right? The student 1 and student 2, the distance between them is height is 1. So you have to take in the graph sheet up to the height of 1. And similarly S4 and S5, the distance between them also 1. Both will be on the same height. The distance between this cluster to the next person height is 2.5. So you have to draw a height of 2.5 and you have to combine them. This is the height of 2.5. And overall you have to combine the whatever the height, whatever the distance you are having between these two, you have to combine these two. This one I have calculated earlier. This I don't know. You have to calculate. Because I have changed the data point, right? These 3 data points I have not changed. So whatever the previous values are there, the same values will be continued. So this value you have to calculate. You calculate. Right? So the height is Euclidean distance. Now what is the advantage of making the hierarchical clustering like this? Sir, at the end everything forming to 1 only, right? Then what is the use? Now this belongs to 1 cluster. This belongs to 1 cluster. Right? Is that clear? So now within this again, if you want to make this one into, for example, like 3 clusters, if you want to divide into 3 clusters means this is 1, this is 1 and this is separately 1. If you want to make the same thing into 2 clusters, you have to draw a line here so that this is 1 and this is 1. If you want to make them into 4 clusters, you draw a line here. Draw a line here. This is 1 cluster, this is 1 cluster, this is 1 cluster and this is singly, separately 1 cluster. Based on your line, it will be decided. So here, sir, optimum number of clusters. How to identify the optimum number of clusters? This is one of the difficult one in the hierarchical clustering. How to identify the optimum number of clusters is not possible in the hierarchical clustering. just generally, whatever the line we are going to draw below to this. For example, if you want to make them into 3 clusters, means we are going to consider these are the 3 clusters. So hierarchical clustering is applicable for the small data sets. Wherever we are having we want to see which are very close to each other. That at the time they are going to form the hierarchical clustering. Is that clear? So, sir, how this line you are going to draw? There is any rule for this line? Whatever the yellow line is there any rule? Miss, there is no rule. What is the maximum rule is? Generally, whatever the maximum height is there, out of all the height, one height will be very high, right? That height, half of that height we are going to consider. Half of the maximum height we are going to consider. Okay, but it is not the rule. That is not the rule. So that is one of the disadvantage of this algorithm. So sometimes it is difficult to identify the number of clusters by the dendrogram. That is one of the disadvantage. Advantage is we can easily understand which are very close to each other by seeing the dendrogram. Dendrogram has the advantage, it will identify which two are very close to each other. At the same time, optimum number of clusters we can't identify from the hierarchical clustering. So optimum number of clusters we can go with the k-means. If you want to see the which are close to each other, that we are going to apply in the hierarchy. Is that clear? Done? So let us do the coding part. Okay. So I'm importing NumPy, pandas, and warnings. What are the warnings are there? Some warnings. If I'm getting any warnings, automatically it will delete that warnings. Right? Or here I'm going to work on the malls customer data set. There is a customers with respect to a particular mall. One mall is there, and in that mall we have got with respect to different customers. So this is the customers where one of the customer is male and age is 19 and annual income is $15,000. Okay, in terms of thousands of dollars, $15,000 and the spending score. So this customers, whatever the customer data they have collected is from the malls within a mall, they have collected all the details. So some people, okay, people will be at different categories. Some people will get a good salary, means instead of good salary, high salary. They will get a high salary, but they will not spend more. They will save everything. Okay, they will try to save. Some people will be there. They'll get a high salary, and whatever the salary they are getting, they'll spend everything. Okay, like me. Okay, they'll spend everything. Whatever the money they have got, they'll spend. They'll not have any savings in their bank account. Nothing will be there. Every month ending, again new only. Right? Again waiting for the next week, next month, first week, again salary to be credited. Right? Some people will be there. They'll have the low salary. For low salary also, they'll spend very high. Though they get a very low salary also, they'll spend. Okay. Some people will be there. They'll get a low salary, and that low salary only they'll save that one for the future purpose, whatever the requirements. So we are having different types of people. So generally they have observed with respect to for whatever the customers they have got, they have taken the gender, age of the person, and what is their salary. They asked their salaries, or they asked with respect to a feedback form or with respect to a survey form, where they have filled the values with respect to whatever the salary and based on the level of spending. So for example, one person was got with respect to salary and level of spending of this salary. So this is the percentage out of 1 to 100, right? So if you observe in this, females will have with respect to high percentage, spending score will be very high when compared to males. Okay, if you take the average, just to apply the group by function, you will observe that one. Male spending score is very less when compared to females are very high, right? Now, here the data set, what are the data set is there? This is data set of 200 entries, completely of 200 entries, where I'm having with respect to customer ID, gender, age, annual income, and spending score. And there is no missing values. There is no missing values. Now, in this, one of the column is, since there is no missing values, I don't need to treat the missing values. One of the column is having with respect to gender, where text data is available. So I want to do the encoding. So data pre-processing will be the same. We are not going to change the data pre-processing. First, we are going to clean the data and we are going to do the encoding. Everything is common. So just I'm going to apply the encoding. Once I apply the encoding, now I have got with respect to the male, wherever the male is there, it is considered as 1. wherever the females are there, it is considered as 0 because label encoder I have applied and automatically it will apply the female alphabetical order. Female will come with 0, male will come with 1 as per the alphabetical order. Sir, how label encoder you can apply, sir? Label encoder you have to apply only for the ordinal data, right? How you can apply for nominal data? If you are having a binary class, for binary class, whether it is a nominal or ordinal will be the same only. There will be no difference. For example, if I apply the encoding, one hot encoding, if I apply on the gender. So what happens? I'm going to get female and male, out of which drop first is equal to true miss. Again, this one only will be dropped, right? Wherever the male is there, it will be having 1, 1. Wherever the female will be there, it is going to be 0. In this column, wherever the female is there, it is 1, 1. Wherever the male is there, it is 0. If you drop this one, automatically you will get this one only, right? The same thing is here. If for binary class, if you do one hot encoding or get the miss, or if you do the label encoder, both are same. There will be no difference. For multi-class only, the difference you can see. Okay. For if binary class, nominal data or ordinal data, there is no difference. Right? Now, X, I am going to consider the X. What is the X variable I have to consider? That is this from this column to this column. Apart from this one, you have to drop this column. You should not consider this column. You have to drop this column because this is a customer ID. ID will be different from person to person. There will be no common pattern will be there. So we are going to consider 1, 2, 3, 4. So column ID numbers 1, 2, 3, 4. So I am going to consider by using the ilog. Either you can use ilog or you can use with respect to df.drop function also. Both are same. So ilog, where I am going to consider all the rows. Before to comma, colon means all the rows. This indicates all rows. After colon, I have kept 1 to 5. 1 to 5 means 1 to 4. 1 to 4 means whatever 1 to 4 is there, that is 1, 2, 3, 4. 1 to 4 means these 4 columns it is going to consider. So I'm going to consider these 4 columns, and if I apply X means those 4 columns will be considered. And if you want as an array, if you want to convert as an array means dot values. Dot values gives you the array. If you don't keep the dot values, you are going to get as a data frame. That is the difference. How to convert a data frame to array means just you have to apply dot values, right? This already I have told you in the pandas, right? Now, modeling. In the K means first we have to identify the best K value, which is the best K value. So how to identify the best K value in the K means? Using the elbow method. What is the elbow method? Meaning of elbow method? How the elbow method is done? How the graph? Based on the clusters, number of clusters on the x-axis, that is 1 cluster, 2 clusters, 3, 4, 5, 6, 7 versus WCSS value. So here what I am going to do means, here I am going to apply for K in range of 1 to 11. 1 to 11 means first K value will be considered as 1 and it will be fitted on the data and it is going to calculate the WCSS value. It will calculate some WCSS. And after that, K is equal to 2. Again, it will be fitted on the data. Again, it will calculate the WCSS. As the K value increases, always the WCSS value will be drop. That is low. So here, whatever the WCSS value is there, that WCSS value is called as K means dot inertia. Inertia means within WCSS. So this value I am going to append to the empty list. So for K is equal to 1, for K is equal to 1, this is the WCS. K is equal to 2, K is equal to 3, K is equal to 4, K is equal to 5, 6, 7, 8, 9, 10. For each of them, K is equal to 1 to K is equal to 10, I have got the WCSS value. Now within this, I want to identify the optimum. Optimum, how to identify? By using the elbow curve. Now elbow curve, where we are going to get the flat one. Now see, this is the first one is WCSS with K is equal to 1. WCSS value is 3,08,862. For K is equal to 2, the WCSS value is 2,12,889. What is the difference between these two? Difference. What is the difference? Approximately only, not exactly. Approximately it is 96,000. Okay, approximately it is 96,000. Sorry, 96,000. Approximately it is 96,000. Right? Next, if you go with the K is equal to 3, what is the WCSS? That is 1,43,391. Okay, what is the difference approximately it is with respect to the difference between these two? What is the difference between K versus 2 and K versus 3? What is the difference? Which is nothing but approximately 70,000. Approximately 70,000. Next, K is equal to 4. What is the value? That is 1,04,414. Now, what is the difference approximately? Approximately it is 40,000. K is equal to 5. That is 75,542. Approximately the difference is 25,000. K is equal to 6. That is 58,350. Approximately the difference is 17,000. K is equal to 7. 51,460. The difference is 7,000. So just every time the difference is obviously decreasing, but here the difference is 96,000 to 70, 70 to 40, 40 to 25. Now if you calculate the difference between these two, now within the difference to difference again, how much it has dropped suddenly? 26,000 it has dropped. Here 20,000 drop. Here 15,000 drop. Here just 8,000 only drop. 8,000 only drop. If you observe this one, the difference was dropped is just 8,000. The difference was dropped is 10,000. So where the difference was dropped, the starting point of the thing is considered as the optimum value. So K is equal to 5 is the optimum number of cluster. From where the difference is too low, the difference is not much change. There is no much change. That is the best one. Is that clear? For example, iPhone 11 Pro and iPhone 12, if both of them are same, there is no much difference between both of them, assume. Then which one is best? Which one is low cost only, right? If 11 Pro is, for example, both of them are, this one is 58,000 and this one is 65,000. Okay, approximately both of them are having the same features, no difference, not even one difference also is there. Then what is the use of purchasing iPhone 12? We'll go with the 11 Pro only. 7,000 will be saved. If there is a difference, the difference we are going to consider. If there is no difference, what is the use of considering? So like that, if you consider the difference was drastically reduced with K is equal to 5. So from where the difference was suddenly was dropped and very less difference is there, that is called as optimum K value. That even you can even observe in the elbow curve also. So I am taking the elbow curve, that is nothing but PLT dot plot. What is meant by PLT dot plot? Line plot. So line plot on x-axis, I am going to take the range of 1 to 11. Range of 1 to 11 means nothing but list of 1, 2, 3 up to 10. On the x-axis, on y-axis, I am going to take the WCSS values. 10 CSS values, 10 values of x. So I am going to get a plot like this. X is 1, 2, 3, 4, 5 up to 10. WCSS value for each of them. I am going to draw the line plot between these both, that is x and y. So by applying the line plot, I have got the line plot like this. Now from this line plot, where is the elbow value? You can see optimum number of K value. You can clearly observe this one is here. From here, it is almost flat with respect to. From here to here, there is still angle is like this. This one is almost flat line. You are going to have a flat line like this. So from this, we can identify the K is equal to 5 is the optimum number of clusters. Once we identify the K value is equal to 5, now using that K value, we are going to design the model. K is equal to 5 with initialization is equal to K means plus algorithm. Random initialization trap, I have told you, right? So we have to consider the K means plus algorithm, and using this K means plus algorithm, we are going to predict, fit and predict on the X. Now 200 records, these are their clusters. Total 5 clusters are there. Cluster number 1 is 0, 2, 3, 4, 5. Okay, so this first record belongs to cluster 0. This belongs to cluster 4. Second record belongs to cluster 4. Third record belongs to cluster 0. Fourth record belongs to cluster 4. Sir, instead of like this, I want to see as a data frame. So create a data frame. Whatever the predicted answers are there, create the data frame for that and concatenate to the original one. Now you can see for each record what is their cluster. Is that clear? So create the data frame, pd.data-frame k means, and write the column name called as cluster. Columns is equal to cluster. Write the name called as cluster. So the column name I have created by using the cluster, and you create this one. Now you can see each record to which cluster they belongs to. So the first record belongs to 0 cluster. Second record belongs to 4th cluster. Now, whichever the clusters 3, okay, cluster number 3, those records you are going to identify. You are going to get the records which are related to cluster number 3. So these records, total 79 records are there related to cluster number 3. For these 79 records, you are going to create an offer for these people separately. Who belongs to cluster number 2, those people you are going to create separate. Is that clear? Now, if you want to see the scatter plot, how we have worked on the PPT, in the PPT, we have taken the scatter plot, right? Now, scatter plot, for example, this is the X1 variable, X2 variable, X3 variable, X4 variable. For 4 variables, can we draw the scatter plot? No, right? So 2 variables only we can draw the scatter plot. Bivariate analysis. Scatter plot is bivariate analysis where we can take X1 and X2. Only 2 variables we can take. So what I'm going to do is, in order to create the scatter plot and to show you, I'm going to create this one. It is not mandatory. To show you this one, to understand clearly, I'm showing this one. So where I'm going to select the third column. Third column is nothing but spending score. Whatever the spending score is there, annual income and spending score. These two I'm going to consider. This one I'm going to consider as A and this one as B. Only these 2 columns I'm considering. Sir, why you are considering only 2 columns, sir? Why you are not considering entire data set? Because to make the scatter plot. To show you the scatter plot, I'm considering only 2 columns. The reason behind that is to show you the scatter plot. So now you can see the scatter plot where you are having on the x-axis annual income versus y-axis their spending score. So this is the original data. Now after clustering, now this is the data. This belongs to 1 cluster, 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 and this belongs to 1 cluster. This diagram, to show this diagram, I have considered only 2 columns. This diagram I can create only on the scatter plot. On scatter plot, I want to create this diagram is, I have to select only 2 columns. I can't select all the 4 columns. Using the 4 columns, if I throw it into the scatter plot, draw the scatter plot, plt.scatter. If I give x1, x2, x3, x4, if I give like this, it will throw an error. Scatter plot can take only 2 variables at a time. So I'm going to consider between x3 and x4. Only 2 variables I have selected. Before clustering, this is the original. Before clustering and after clustering, you have got like this. Now, from this, we are having different, total 5 clusters are there. Cluster 1 is with respect to high income and high spending score. So target these kind of customers by sending a new product alerts. So they are having interest on spending, right? They spend every time. So whoever are having the spending score, whenever there is a new product, immediately send the message. They'll be attracted. Every time they want to shopping. Their main interest is with respect to shopping and they want to spend the money. Okay. Sir, that is their category. The people will be like that. So whoever the people are spending more amount. So for those people, you send the, with respect, whenever there is a new product, immediately send the alert. For example, high income and low spending score is there. They are having a good income, but their spending score is very low. They'll very carefully, they will observe everything and finally they will invest. Okay. This kind of people, for those people, what we have to do is, we have to take the feedback from them, which type of product you are interested. So that we have to create for attracting this kind of people. Right? Next, average income, their average income versus average spending score. Target this kind of customers by providing with the low cost EMIs. If you provide with no cost EMI, these people easily attracts. They're already dilemma 50-50. For 50-50, if you give one more offer, free, it easily attracts. Right? So we are having with respect to this category people, we are going to provide with respect to no cost EMI. Low income, but high spending score. Okay, their income is very low, but they're having a very high spending. For this type of people, whether we have to attract or not to attract will be depend upon your individuality. Okay, if you feel that sir, their low income, sir, don't attract like that, sir, miss, don't attract. No, sir. For us, business is important, miss, attract. That is depends upon you. It is completely depends upon the policy of the mall. Whereas low income and low spending score is there. Like income score is low and spending score also low, miss, leave them. Don't disturb them. Okay, simply leave them. Okay, don't target these customers since they are having low income, need to be saved money now. So simply leave them. They'll save their money. Right? Is that clear? So like this, based on the observation. So generally we are going to get with respect to whoever having the high spending score, those people they'll send whenever they'll try to attract more number of people with high spending scores. High spending score or high income. If the person is having a high income, but he is not spending, means they'll try to attract him by giving new offers. He is having the money, right? So they'll give the new offers to attract that money, to take that money from him. Taking the money from others is called as business only, right? Business, right? Next one is hierarchical clustering. K-means clustering coding is clear. This one, this PLT I have drawn only for understanding purpose. Generally in the real time, just we are going to do this one up to here, right? Directly we are going to predict on the extra, whatever the data, predict on the data, complete data, and directly you select this one. And belongs to which type of record. For example, tomorrow there is one more person. So, exam here I am having a person, male, category is male. Okay, gender is male. Age is with respect to 30. Annual income is around $80,000. 80,000 means 80. Number is 80. And spending score is 85. Okay. Now, to which category this person fall? Once your model was ready, use the model.predict. Use the model.predict, and inside that you have to give the data frame. So you have to use double square brackets. As the input, you have to give data frame. So data frame where male should be converted first. You can't give directly the male. If you give the male, means it will throw an error. So the male should be encoded. Male is nothing but 1, right? So 1, 30, 80, 85. You give like this, it will predict the answer. So whatever the model you have created, so here the model, what is the model name? K-means is the model name. So K-means, using the K-means model, you are going to predict whether this person. So K-means is the model name. K-means dot predict. And so 1 comma 30 comma 80 comma 85, and see to which cluster he belongs to. X has 4 futures, but K-means is expecting 2 futures as the input. So I have given the K-means again. I have rechanged, right? So first let me execute this one once again. Now K-means is this one. Okay, now it will work. Now what is X? Where is X? X is this. Okay, done. Okay, it belongs to cluster 1. It belongs to cluster 1. So in this way, you are going to predict. Here prediction is possible, but evaluation is not possible. That is the difference between the classification versus clustering. Here there is no actual value. Whether it is a correct answer or wrong answer also, there is no actual value. Okay. So in order, how we are identifying this one is based on the distance. Just we are calculating this particular data point. Whatever the, see, for example, there is a new data point. You are having a new data point like this, one data point, completely new data point. Now what you are going to do for this data point, whether it belongs to this cluster or this cluster or this cluster or this one means you are going to calculate for this data point to centroid distance, and distance. Out of all of them, which distance is lowest one, you are going to convert into that one. Right? Just is applying the concept of distance formula. For this particular customer, there is a customer like this, to which cluster he belongs to miss, just you are identifying the distance. For each cluster, you are going to calculate the distance, and out of all the distances, which distance is low, that one you are going to select. Is that clear? Next one is hierarchical clustering. So, that is, I'm going to import NumPy, pandas, again, mall customer, same data set. There is no difference in the data set. Again, same shape, 200 records into 5 columns. This time I'm directly considering that last two one, and the same scatter plot, same to same. Before to this, whatever the scatter plot you have got here, the same scatter plot. Okay. And here we are going to take import scipy.cluster.hierarchy as SCH. And SCH.linkage, I'm going to use the linkage called as ward. Ward means nothing but centroids. It is going to select the centroids. And I'm going to form the dendrogram. So it is going to form the dendrogram like this. Right? So then in the dendrogram, if you draw a line here, whatever the line is there, so what is the total distance from the starting to maximum? What is the maximum distance is 400. 400 is the maximum distance. So 400 divided by 2. Whatever the 400 is there, whatever the value you are seeing here, divide by 2, half of that, and draw a line. This is one cluster, second cluster, third cluster, fourth cluster, and fifth cluster. Optimum number of clusters we can get in the dendrogram like this, but this is not the rule. That is not the rule, basically. So here also we are going to use the same agglomerative clustering. Clusters is equal to 5. Affinity is equal to Euclidean. Affinity means nothing but distance. Distance is equal to Euclidean, and linkage is equal to ward. And you are going to fit and predict on the X. Again, you are going to calculate the same thing. Again, you will get the same answers. Again, you are going to create the same cluster. Again, you are going to concat. Right? So this is using the hierarchical clustering, and you are identifying the clusters and the group of the people. And if you want to check this one, right? The scatter plot is this. So similarly, how you have got the scatter plot here, the same type of scatter plot. Optimum number of clusters. So for what purpose we are going to use K-means? K-means is the best one. Best clustering technique is K-means. And where we can identify the optimum number of clusters in this. Optimum number of clusters is best one is K-means. So for this data, optimum number of clusters is 5. But which records are very close to each other? If you want to see the dendrogram, is the dendrogram you can see only in the hierarchy. Hierarchical cluster tells us with respect to the which records are very close to each other. For example, here 200 records are there only. We are having the dendrogram like this. We can't identify clearly. For example, 2 lakh records are there, means there is no use of dendrogram only. Dendrogram is used when we are having limited number of data, not with respect to large amount of data. Right? So hierarchical clustering we are going to apply when we are having on the small amount of data, and in order to check which are very close to each other. So recently, Russia-Ukraine war is there, right? So in this Russia-Ukraine war, whatever we are having, the UN, that is United Nations Council, in that recently there is voting was there. In that voting, some of the people has participated and some of the people has ignored. Okay. Related to continue with respect to some kind of sanctions on the Russia or not. Okay. Now they have checked how many countries are supporting Russia. How many countries are supporting with Russia and how many countries are against with Russia. And they have formed the cluster with respect to the 2 clusters. One is with Russia, countries with Russia, and countries enemy of Russia, opposite of Russia, opposite to Russia, right? And they have formed the hierarchy. Hierarchy means this team comes under one part. So the European countries, whatever the European countries are there, this belongs to one cluster. For that one cluster, US is very close. Okay, US, Canada belongs to one cluster. These two are very close to each other. The distance, just we are calculating the distance. Distance means not with respect to country, not that distance. With respect to the trade, how much trade they are having together, what percentage of trade they are having. US is having very high trade with respect to Canada. And for Canada people, there is no requirement of visa also to enter into the US. Right? So these are the advantages we are having. So these people belongs to one cluster. Complete European countries belongs to one cluster. Canada and US belongs to one cluster. And China and Russia belongs to one cluster. They belongs to one cluster. And for this one, the India belongs to one cluster. It will be added for this cluster like this. Right? So just they have observed the hierarchy. So based on the hierarchy, they are identifying which are the very close countries. So since the data is very small data, so there we are applying the hierarchical clustering. For example, we are having with respect to 10 lakh in this India, total 130 crores population are there. Which two are very close to each other? If you do the dendrogram, means the first the system will die, and there is no use of doing the dendrogram also. There is no use of dendrogram. Now, sir, in India, complete India, during the COVID situation, they have divided into the clusters. If you have listened the PM Narendra Modi speech, he has used the word called as clusters at that time. He has created the clusters called as orange cluster, green cluster, and red cluster, zones. Each zone is called as cluster. At that time, they have formed the entire India into 3 clusters. So they have divided the data into 3 clusters. The number of clusters is predetermined. Before itself, they have selected that one. And based on that, they have divided the data. And for red zone, the separate precautions or separate sanctions or separate instructions was given. For orange zone and for green zone, differently they have treated. Right? And lockdown also has changed from city to city at that time. For Maharashtra, there is a lockdown. For Telangana, there is no lockdown. Because it comes under different cluster. Right? So during that COVID situation, they have done the pure clustering technique and they have worked on that. Completely in the back end is clustering. Not machine learning, data science. They have applied the data science. Modi has not applied. Modi's team has applied that one. Right? Modi team has applied the data science concept and they have divided the entire data so that the administration work was made easy. Right? Analysis, completely analysis. Clustering best example is COVID situation. In the real time, in the interview, if they ask you any clustering example, you can say with the banking sector to identify the similar kind of customers, or in the retail industry, in the malls, or with respect to some kind of this COVID situation. These are all the examples. Right?